My name is Kylie Fodder, and this is my speech. Did you know that we use negative numbers every single day of our lives? Every time we go to the grocery store and pay for something, we experience a loss of money, or a negative. Up here in Maine, we experience negative temperatures quite often. Or maybe in elevation, there's a positive elevation, which is above ground level, and there's a negative elevation, which is sea level. Because of these facts, it is very important for students to be able to grasp and understand the concept of negative numbers. However, it's also very confusing. It's a brand new concept that students now have to understand, and because of this, they struggle really hard. There's also just some confusion the difference between subtraction signs and negative signs. Now, it's not only students that struggle with this, it's also teachers. There's no easy way to teach negative signs. There's no black and white. Some students grasp it really easily, or some students don't. And because of this, teachers struggle. There's also been the creation of random teaching rules, such as 2 negatives make a positive, or same sign add, different sign subtract. On the outside, this sounds really good. However, if you're given the problem -2 minus 4, a student can now look at that and say, oh, it's +6 because it's same sign add. However, we know the real answer is -6. So you can see how this can be very, very confusing. So what is a negative number? By definition, it is less than 0. It is also located to the left of the number line. Hopefully you can see this, because you can see here's 0, and there's -1 and -2. So negative numbers by definition are less than 0. Some very common examples of negatives, as we said before, is money or debt, and then negative temperatures and negative elevation. There's also some other examples such as sports statistics. So I'm a volleyball player, and if you are hitting in the negatives, you're doing pretty bad. But the negative numbers are used every single day, and that is why it's very important for students to be able to understand this. Now, let's talk about how to teach negative numbers. There's a very easy way, a very common way, that's called number line visualization. Here's your number line. And now, according to Lakoff-Nunez, there is a concept called move along a path. So for example, if we have 2 minus 4, where do we end up? Here's the 2, and you go -4, 2, 3, 4, and that's where we end up. Students sometimes have a hard time being able to go below 0, but by enforcing the move along a path method, you just skip right over it and keep on going. And then you ask yourselves, where do you end up? And there's your answer. Another example is 3 plus -1. So if you run to the negative, you go to the left. If it's positive, you go to the right. This example has a negative. So you're at 3 minus 1. Where do we end up? It's number 2. Another couple examples are -2 and subtract -3. Now this is where we get confusing, because now you have to think it through. However, if you teach the whole same sign add, then you'd be able to understand it's -2 plus 3. Where do we end up? But you can see how this can be very easily confusing. Another example is a hot air balloon ride. This one's really fun. So imagine you have a hot air balloon. Now positive numbers equal balloons, and negative numbers equal sandbags. Obviously, if you add sandbags, you're gonna go down. If you add balloons, you're gonna go up. This is a really easy visualization for students to be able to understand and grasp negative and positive numbers. However, the big flaw is there's no basis for 0. There's no, okay, the balloon stays here, that's 0. If you add balloons or add sandbags, it's very confusing, and a reason why this method isn't used very often. However, it's a good way to represent the fact that negative numbers decrease value and positive numbers increase value. The very last method that I'll talk about today is my favorite, Harry Potter and the Cloaks of Invisibility. So the wizards equal positive numbers, and the cloaks of invisibility equal negative numbers. I drew up an example right here, as you can see here in my wizards. So we're saying that 3 wizards plus a cloak of invisibility equals what? You can also look this as 3 plus -1 equals what? If we think about it as the cloak of invisibility is hiding a wizard, we can now easily see that we have 2 wizards remaining. Another example is 2 wizards plus 3 cloaks of invisibility equal what? You can also visually see that 2 of these cloaks of invisibility will be placed over the 2 wizards, and that leaves us with 1 remaining. This is a really, really fun tool, and it also helps students be able to visualize and see what the negative sign equals, or what the negatives mean and what positives mean. So, in conclusion, it is very important for students to be able to understand negative numbers, and it's also very important for teachers to understand negative numbers. The more of an understanding you have means that the more you'll be able to push onto your students, and the more they'll be able to understand. Learning negative numbers helps students with critical thinking. It also builds a solid mathematical foundation. Can you imagine being able to do algebra or geometry without an understanding of negative numbers? That's why it's very crucial for students to learn. And like we said before, there's also several real-world uses. There's such concepts such as money and debt, and if a student does not know what negative numbers mean, they may never know what debt means, and that could be very harmful. But thank you so much for listening, and have a lovely day.